Hi, today I will walk you through problem 3 on assignment 4. So this problem has 4 parts, and it will show you how actual instructions will work in pipeline data path. So for the first part, it asks us to show or list all the dependencies in the following code. And for this part, we need to pay attention to the registers that are being modified to see if they are being used in later instructions. So in first line of code, we see that register number 8 is being modified. And in second line of code, we see that register 8 is being used right away. So we have a dependency over here. In the third line of code, we see that register number 8 is being used again. So here we need to be a little bit careful because we want to use the register value that is most updated. So we notice that register number 8 is being modified again in second instruction. So we will have dependency between second and third instruction instead of first and third instructions. And in fourth line of code, register number 6 is being used. And we see that register number 6 is being modified in the load word instruction. So we have a dependency over here. And register number 8 is being used again, and we have dependency between sub and add instructions. So this is the first part of the problem. So now let's look at the second part of the problem. It asks us how many cycles are required to execute all instructions, assuming that there's no forwarding logic exists. So if we do not have forwarding logic, we need to add 2 stalls in between all our instructions that are back to back. So let me explain to you why that's the case. So say if we have add and the sub instructions back to back. So the add instruction will have 5 stages: IM, reg, ALU, DM, and reg. So if we do not add any bubbles in between, what will happen is that sub instruction will start from here: IM, reg, ALU, DM, and reg. So notice that the register number 8 in the add instruction will be updated in the last stage, which will happen in the 5th cycle. And the register number 8 in the sub instruction will be updated in the 2nd stage, which will happen in the 3rd cycle. So we cannot go ahead of time and use the register value that is not yet being updated. Otherwise, we will use the wrong value. And what we'll do is we will add 2 lines of bubbles in between. So we will do 2 lines of stalls. And the sub instruction will start from here: IM, reg, ALU, DM, and reg. So what will happen now is that the stages are lining up. So what will happen is in the first half of clock cycle, the register number 8 will be updated. And in the second half of clock cycle, it will be used by the sub instruction. So the dependencies are solved by 2 lines of stall. So by the same logic, we will have 2 lines of stall in between sub and load word instruction because we have a dependency over here. And we will have 2 lines of stall in between load word and add instruction because we have dependency over here. So to count how many cycles are required to execute all instructions, we need to add 4 instructions. And we need to add that by 4 cycles to finish up the pipeline. And we need to add total of 6 stalls. That will give us total of 14 cycles. To calculate CPI, the formula is number of cycles divided by number of instructions, which is 14 divided by 4 instruction, which will give us 3.5. And that's the second part of the problem. Here's the third part of the problem. It says that the pipeline data path on the figure below shows the 5th cycle of executing this program. And we are asked to figure out all the question marks in the figure below. So first we need to figure out what happened in the 5th cycle. So we will have 4 instructions. Each instruction will have 5 stages. And remember that we need to add 2 lines of bubble in between every instruction. So the sub instruction will start from here. And after that, we will have 2 more lines of bubbles. We are interested in the 5th cycle, so it will be this cycle. And both of these will have reg, and the rest of them are bubbles. So let's figure out what happened in the 5th stage first. So in the 5th stage, we are trying to write back to register number 8. And we are trying to use the value from ALU instead of memory, so the mem to reg will have value of 0. And in the 4th stage, we notice that we have a bubble, so we do not care about the register value in that stage. So we will have an X over here. And for the mem write, because we do not want to write random values into memory, so we will have value of 0. And in the 3rd stage, we have a bubble again. So for the same reason, we will have X for this question mark, because we do not care about the register values. And for this question mark, it's basically a mux deciding which value we will use for ALU computation. But we have star over here, so we are not doing ALU computation, so we do not care which value we're using, so we will put X over here. And for this question mark, it's reg write. So remember that we are trying to write value back to register number 8, so we have a value of 1 over here. For the last question mark, it's after an adder, which has input value of PC and 4. So this question mark will simply have value of PC plus 4. And that's the third part of the problem. Now let's look at the last part of the problem. So in this part, we're assuming that data path contains forwarding logic. And we need to use the diagram below to show the forwarding and stars needed to execute the instructions. So remember, all the dependencies between R-type instructions can be solved by using forwarding logic. And let me show you why that's the case. So we will have add instruction here, and we will have sub instruction. So it will have 5 stages as well. Remember, we have dependencies between register number 8. So the value of register number 8 will be updated after the ALU stage of the add instruction. And we need that value ready by the ALU stage of the sub instruction. So that can be solved by simply forward the value from the ALU stage in add instruction to the ALU stage of the sub instruction. So in that case, we do not need to add any bubbles in between. And for the same reason, we can just use the forwarding logic to solve the dependency between sub and the load or instruction, because we have dependency over here. And in the load or instruction, we are supposed to add the value of register number 8 to 4. So it's the same logic as we are executing all the R-type instructions. So we can simply forward the value from ALU of the sub to the ALU of load word. And for the last instruction, it's a little different. because the value of register number 6 in the load word instruction will not be updated until the DM stage. For the load word, we need to decode the memory and load the value before we can know what's in register number 6. So in that case, we need to add a line of bubbles, and add instruction will start from here. And this is the AAO stage of the add instruction. So we need to forward from DM stage to AAO stage. So that will give us 1 stall in between load word and add instruction. So the total cycles of the program, including the stalls, will be 4 instructions plus 4 cycles to finish up the pipeline diagram and 1 stall. That will give us total of 9 cycles. And the CPI will be 9 cycles divided by a total of 4 instructions. So that will give us 2.25. So that's all the problem number 3. Thank you.